theory. Limit comparison test. I'm going to be referring to it as just LCT, limit comparison test. Suppose we start with two series, AN, infinite series, and BN, infinite series, and from 1 to infinity. And then let's assume that we are positive term series. Okay. Which means AN and BNs are greater or equal than 0. Also assume that we can calculate the limit. So if the limit, so what we do is we take a ratio of n, we divide by bn, we take n approaching infinity, and we assume that that limit exists equal to L. And we assume that L is not too big and not too small. So a finite number which is non-zero. Then conclusion of this theorem will be then either both series converge or both series diverge. Let's try to see why. Let's try to see the idea why limit comparison is working. So if limit of an over bn equals well, and then approaching infinity, then for big n, usually we'll say when n is bigger than, say, capital N, n divided by bn is going to be very close to L, approximately equal to L. So from here we conclude that an will be approximately equal to L times bn. Then if we add up all n, starting at that capital N, and we add all the L times bn, starting at capital N, they will be approximately equal. So those two expressions will be approximately equal. So from here, after factoring L outside, we get that infinite sum n start at capital N to infinity is approximately equal to L times infinite series of Bn starting at capital N to infinity. And from here, you can easily see if that infinite series of An is infinite, then it equals L times Bn. So infinite series of Bn has to be infinite too, because L is not 0 and L is a finite number, and L is not 0. The same reason if you start on the right and if you start with Bn equals to divergent equals to infinity, then you multiply by L is still infinity, then you conclude that whatever is you get on the left side, which is sum of n, will be infinity. So that's an idea. Okay, so that's an idea. Now let's try to use it a couple of times and see how we're going to be doing using LCT. I'll do a couple of examples. First example, we want to determine whenever series is diverge or converge. So what's going to be our questions? So diverge or converge. So the first one, we start with a series, say 3n squared plus n divided by n to the fourth plus 10n squared, and from 1 to infinity. We want to LCT it with, so we want to LCT it with. So what I'm going to be doing is kind of rule of thumb. So what I will do is I will do rule of thumb. I see a rational expression, and then for rational expression, I know that higher power will dominate. So 3n squared on top will dominate, and n to the fourth on bottom will dominate. So I'm going to write down 3n squared on top and n to the fourth on the bottom. If you like, we can reduce it into n from 1 to infinity, 3 divided by n squared. So now I want to compare these two series by doing LCT between these two series. So I kind of did rule of thumb here. Then that's how we got a new series. But firstly, let's see how that rule of thumb is going to work. And that's essentially what we're going to be doing often. So I take limit as n approaching infinity. I take the first one. I divide by the second one. And it's up to you how you do the calculations. For example, I will do rule of thumb, and I will again say that highest power dominate. So I'm going to get 3n squared divided by n to the fourth, divided by 3n squared, and I do some algebra here, and I'm going to get at the end 1. So if you like, the algebra is going to be straightforward. So it's 3n squared divided by n to the fourth, multiply by reciprocal, 3 cancels out, n to the squared and n to the fourth, so we're going to end up with 1. So you kind of see that. So that's a nice thing about doing a rule of thumb. If you can do rule of thumb to your series, then you can clearly see what to LCT with, and most of the time we're going to skip that step because rule of thumb will guarantee that the ratio is going to be equal. Now to finish the problem, so what we know is we know that the original series 3n squared plus n divided by n to the fourth plus 10n squared and from 1 to infinity, we're allowed to do LCT with 3 over n squared and from 1 to infinity. Second series is straightforward. We can factor 3 out, so we're going to get 3 times 1 over n squared and from 1 to infinity. And that is convergent because that's P series P equals to bigger than 1. So we turn around and we say the original one is convergent by LCT. Because you remember, if we can limit compare two series, then they do exactly the same. And we can limit compare the two series because the ratio of terms equals to 1. Sum n squared plus n plus 5 divided by n cubed plus n squared plus 100, and from 1 to infinity. I'll do LCT by using the rule of thumb. This base series, on top I have n squared, on the bottom I have n cubed. So I will reduce that into 1 over n, and from 1 to infinity. So my conclusion is that this series is divergent P equals to 1. So my original one is divergent by LCT.